Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Hi. Are you sure you can prepare for product-based companies through this course?
Yes, sitting at home?
No way.
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello Rishit, and good evening everyone. So, those who have joined with me presently, can you please do a +1 in the chat box so that I could get to know your names, and just inform me that I am properly audible and visible, and let me share my screen so that we can very quickly start. Hello Rishit, can you please tell me that whether I am properly audible and visible? Yeah, thank you, Rishit. And tell me that everything is well from my end. Okay, yeah, that's very great. Okay, so tomorrow we were discussing about diameter of a tree, and we had to stop at that point of time. So today we will be continuing with the same thing, diameter of a tree, and I will also be discussing few other important ideas involving pre-computation using DFS, and we will discuss one more problem called rotten oranges. Okay, so yeah, so before I begin, let's wait for a couple more minutes so that other audiences can join. Okay, so let me give you a small introduction that we are having on this series. So this is called practice session for SDE interviews, and in fact today will be the last day of this particular series. And from next month onward, we'll be planning on something else different. Okay, so you can watch the previous recording on the channel itself. And if you are in your second year or in your third year and you are appearing for your internships and placements interview, there's an excellent course called Complete Interview Preparation, which you can basically purchase from the GFG platform. Okay, so that particular course is called Complete Interview Preparation. Okay, and it is an extremely well structured course for your interview preparation. All the important topics are properly discussed here, and if you would definitely like it. Okay, so I would recommend you all to kindly visit and check it out. Okay, so the discussion we will be discussing about graphs and trees today. Okay, majorly we will be discussing about diameter of a tree. Okay, and how you can find it using DFS. And after that we will be discussing about rotten oranges problem. Okay, this is one of the famous problem of multi-source BFS. Okay, and finally we will also be looking into ideas of pre-computation using DFS. Okay, so we will be just quickly going through all these three important topics, and then we can very wrap up our discussion for today. I would encourage you all to kindly stay with me till the very end, and yeah, kindly stay with me till the very end. And the session won't be very long; it will be around max 40 minutes. Okay. So this is about today's session. This you can definitely check out this course, also called CIP course. You can also check out the DSA self-paced course, DSA SP course. It is a beginner-friendly course, and if you're starting with your journey of learning data structures and algorithm, this particular course will definitely help you out. Okay. So before I proceed, let me give you a small introduction about myself. So my name is Gaurav Kumar Shah. Okay. So you can just hit me up on LinkedIn as well if you would like to get connected with me, and you can just type out this name and you will see me. And I'm presently in my third year at IIT Kharagpur. Okay. So, and I'm also a mentor at Geeks4Geeks, and I'm also a software engineering intern at CureFit. So this is about me. So let us begin with our discussion for today. Okay. In case if you wish, you can definitely hit me up on LinkedIn. Okay. So yesterday I was discussing about diameter of a tree. Okay. And so one of you all replied in the comment that diameter of a tree is that, let's say we have a root, and let's say this is a tree. 1 minute. Yeah, so I was discussing about diameter of a tree. So let's say this is a diameter of a tree. Okay, so 8 and 9. So the question is that how would you find the diameter of a tree? So diameter of a tree is basically the longest path that you can make out from this particular tree. So let's say I can see that this would be the longest path, which consists of 1, 2, 3, 4, 5, 6, 7, 7 vertices, and 1, 2, 3, 4, 5, 6 edges. Okay. So in fact, this particular will also be a diameter of a tree: 1, 2, 3, 4, 5, 6. In fact, 1, 2, 3, 4, 5, 6, 7. This also has 7 edges. Okay. So the idea here is to tell you the length of the diameter. Okay. So in case if this question is asked, you should answer that there are 7 vertices or 6 edges, or diameter would be 6. Okay. So this is the idea about finding the diameter. So can anyone tell me a idea that how exactly can we solve this question? Hello, Rishit. Can you tell me what algorithms will apply to solve this question? Okay, so let me tell you. So basically, what exactly we will do is that we will try to run a DFS algorithm from the root. Okay, root of the tree, and then we will go to the farthest node from the root. So in fact, let's say I reach this particular node because this is at the farthest node from the root. Okay, we can also reach this node as well, and this node as well, and this node as well. So, but once we reach the farthest node of the tree, we will store that particular node. Okay, so for example, let's say one of the node is equal to 4. Then again we will run a DFS from this particular node. Okay, the node number 4, and then try to reach the farthest node from this particular node. Okay, so once we again try to do that, we will see that node number 8 is the farthest node again. So the second node that we got is node number 8. Okay, now the idea is to calculate the distance from the node number 4 to node number 8. Okay, so we are basically using two DFS calls to evaluate this. Okay, now we also need to keep a distance array as well. Why a distance array? Because a distance array will basically help you keep track of the distances. Okay, so once you run the DFS for root, you this is basically a distance array. So the node numbers are present here. So after you run you run the DFS. So basically, what will happen for every node, you will get the distance from the root node. So 4 is present at a distance of 1, 2, 1, 2, 3. Okay, so 4 is present at a distance 3. 5 is present also at a distance 3. Okay, 6, 7, 8, 9. So all these things you can basically fill. Now you will only go to that particular node which has the maximum distance, because that will be one end of the diameter, and then again start a DFS from that particular node to the again next farthest node possible. So you start a DFS from 4, and then you again make a distance array, and this time this distance array will compute all the distances of every node from the node number 4. Okay, So once you get a new node, which is basically at a distance of 6 units from the node number 4, will be your diameter. So whatever is the distance of the farthest node from node number 4 will be the answer to your question. Okay. So I hope everyone understood about this concept. Can we try BFS? Yes, basically DFS algorithm will basically help you to do it more efficiently. Okay, and yeah. So what happens here in that is that in DFS algorithm, what happens? You're trying to go into the depth of the tree. BFS algorithm traverses the tree level wise, so it will not help you here. Okay. So what you want is that once you are starting with the root node of your tree, you want to go to the very depth of the tree as fast as possible. So DFS recursively does that. Okay. And BFS algorithm basically traverses the tree on a one particular level. So it will initially go at one, and then it will try to go to the next level of tree, like 2 and 6. Okay. So can we take another example? Okay, I'm telling you. Yeah. So just increase the length of the tree by one, and then the things will become. Okay. So let's say this is 10. Okay. So now once you run a DFS for one, it will return the farthest node that you can get from the root is equal to 10. Okay. So this will return root 10. Now you will again run a DFS for 10. So the farthest node that you can get from 10 would be 1, 2, 3, 4, 5, 6. It can either be 4 or it can either be 5. Okay. So let's assume 4. So the distance between node number 10 and the node number 4 is equal to the diameter of your given tree. Okay. So let me show it to you in the code part. Then I suppose you will be able to understand it properly. Okay. So let me share my Visual Studio's code screen. Okay. Just a minute. Okay, so let me share the Visual Studio code screen, and that would be helpful. Okay, which will show you the code. Yeah. So I hope you can see my screen here. So let me increase the size of the. So yeah, I hope everyone can see my screen. The sharing of the visual Sublime text. Okay. So yeah. So the thing here is that first of all, what we are doing. Yeah, so what we are doing basically is that we are taking the input n, okay, and now we are creating the tree. So this is how we create tree in the form of an adjacency list. Now we are running a DFS called DFS 1, 0, 0. Why exactly is this? Let's see into this particular code. So this is void DFS. This is accepting the vertex from which we are starting, which is initially the root. We are also keeping track of the parent array and the depth array. Okay, why we need the depth? Because we want to calculate the distance of the farthest node from our root node. So what we are doing basically is that depth of vertex will be equal to depth. Okay. Hmm. So after that, what we are doing basically is that if now we are iterating across all the child of the vertex of the present vertex. This is basically the standard code for DFS. And if the child is equal to the parent, we continue. Otherwise, we do a recursive call for the same DFS function, passing with the depth plus one. So once we are moving to the next node, the depth will increase because the DFS algorithm basically goes down to the depth of tree. So that is the reason we are putting depth plus one. After that, what will happen once this particular code gets run for the root node? So in the depth array, I will have all my distances. Okay. So as you can see, I have maintained this particular. I call DFS for the root, and then I run across all the depth array. And if the depth array is greater than the maximum distances, I just take the depth of I, which means that I am basically storing the node number which has the maximum depth. Okay, so if I run using that tree, my max depth max, we are actually using the same depth array because this depth array will get overwritten. Okay, because it will we are running from 1 to n in both the cases, and the depth array will be overwritten. And after that, what will happen? Whatever value we are getting stored in this max distance will be our diameter. Okay, so this is the answer. Okay, so let me write the answer. Your answer would be max distance. Okay, so this will be the answer, and you can just output that. And the second and max IDX will contain the node number which is farthest from the node which we got in the first run of DFS. So basically, running DFS twice is helping us calculate the diameter of the tree. I don't think so, Rishit. Like, was my voice audible properly? Lines 141 to 146. Okay, yeah. So lines 141 to 146 is basically we are calling the DFS function once again because we once we got the farthest node from the root. Next step is to get the farthest node from the that particular node which we just got. Okay, it's a two-step process to calculate the diameter. Okay, so this is the second DFS call. Let me just mention this is the second DFS call. Okay. So second DFS call is basically the from node which is one end of the diameter, and this will basically give you the node which is the other end of the diameter, and overall you can get the answer. Answer would be max distance. Okay, so this is the concept of diameter. Okay, so let us move then. Yeah. So let me stop sharing my screen and let's move to the whiteboard. Okay, so if you have properly understood this concept, can you please do a +1 in the chat box so that I can move to the next concept? Okay, so I suppose the diameter part is clear. Now let's move to the question of rotten oranges. Okay. Yeah. So I suppose this question has been previously been done by me only in one of the session. Okay. Let me give you all the link of the question on the chat box that you can basically try to solve on your own, or you can just Google rotten oranges GFG. Okay. So this is one of the widely used, widely solved problems, and have been appearing in interviews for quite a lot of time. So let me share it to you all in the chat box. Yeah. Yeah. Okay. So let us proceed then. So let's read the problem statement and then. Okay, so the problem statement says that you're given a grid of dimension n into m, and where each cell in the grid has values 0, 1, and 2. So yeah, 0 means it is an empty cell, and 1 means the cell have fresh oranges, and 2 means that the cells have rotten oranges. Okay, so then the question is that you have to determine what is the minimum time required to rot all the oranges. Rotten orange is at index I comma j will basically rot if you can find any of the rotten oranges in all the four directions of that particular orange. Okay. So Rishit, what do you think will be the idea that we can utilize to solve this question? So yeah, we have to make sure that we are also doing it in minimum amount of time. Okay, because we have to output that. So let me just enter a text. So let's suppose this is the oranges grid that we are given. Okay. Now 0 denotes an empty cell, 1 denotes a fresh orange, and 2 denotes a rotten orange. Okay. So this is the concept, and we basically have to return the minimum time which all the fresh oranges will become rotten. So this particular rotten orange can basically rot this orange in 1 unit of time. This particular rotten orange can rot this orange, and this particular rotten orange can rot this orange, and this particular rotten orange can rot these two oranges at the same time. Okay, so this will get rot, and this will also get rot. This will also get rot, and this will also get rot. So finally, all the ones have been converted to 2. So we have to output the minimum amount of time, and every rotting operation takes 1 second. Okay. So basically, what can happen here is that, let's say I have 0, 0, 2, I have 1, I have 1, and I have 1, I have 2. In 1 second only, all the oranges are getting rot. So in that case, our answer would be 1. Okay. And if it is not possible to rot all the oranges, like let's say that after the entire operation, there is a single orange which is still fresh. So in that case, you have to output -1. Okay. So did you understand this question properly? Can we use multi-source BFS? Yes, Rishit, we will basically be using multi-source BFS only to solve this question. Okay, so can you tell me that why exactly we have to use multi-source BFS and not just BFS? Like the difference between both are basically is that the starting point are multiple in case of multi-source BFS. Okay. So yeah. So Rishit, can you give us any proper explanation that why multi-source BFS would work and not normal BFS? Complexity, no, the time complexity of both would be same. The time complexity of multi-source BFS or the BFS is basically the number of edges plus vertices. Okay, that is the number of vertices plus edges. So let me just write it down here. So basically, the time complexity yeah. So the time complexity would be we go of V plus C for both the idea that why we are using a multi-source BFS and as in the logic of the question. Minimum amount of time in which find the minimum amount of time we have to make sure that all the rotten oranges are rotting every other oranges parallelly. Okay. It doesn't mean that let's say you start a BFS from 2. So 2 will only rot in the first second this particular orange, but it makes sense that we can actually utilize the first second to recharge them rot all the so so that is the reason that we are using multi-source BFS. Okay, why we are using multi-source BFS? So the idea here is that we want to have the minimum amount of time that we should get for sorting all the oranges, and that is the reason we are proceeding with minimum multi-source BFS. Okay. So I have already pasted the link of the question on the chat box. You can try it out yourself, and I will be discussing the code right now. Okay. So okay, so let us proceed to the coding. Yeah, so the reason basically is that we want to find the minimum amount of time that will take to rot all the oranges. Now we can only achieve minimum amount of time if we are rotting all the oranges simultaneously. Okay. Okay, so voice and video is freezing. So let me just a minute. Yeah, so I was saying that basically we want to find the minimum amount of time, and we can only achieve minimum amount of time if we are rotting all the oranges simultaneously. So in order to start with the queue, we will insert all those oranges, all the coordinates of those particular oranges which basically are rotten initially, and then we can start proceed with the BFS algorithm, and every rotten orange in the queue will start rotting its nearby oranges, so thereby achieving a minimum time. Okay, so let us have a look at the code here. So let me share the code screen, and then we can, uh, yeah, just a minute. Let me share the code screen. Okay, so yeah, I hope the code screen is already visible to everyone out here. So let me first do a bit of zooming, not so much. Okay, yeah. So first of all, we have to make sure that we are declaring a queue, because queue is very important, because we want to do. Uh, okay, so now what we are doing, basically we are traversing across the grid, and if the value of grid is equal to greater than 0, it means we are doing count plus plus. Why count plus plus? Because we want to know the total number of oranges present. Now if it is equal to 2, 2 means rotten orange. So we will insert that into our queue. Okay, so our queue is basically a vector of queue, so that we can insert two values I comma j in the form of coordinates. We have also created a direction vector. This specific vector will help us traverse the four direction of any particular cell. Now what we are doing is that we are just running our BFS algorithm as usual. So while q is not equal to empty, what we are doing, we are going across all the elements of the queue. Okay. So first we go across all the elements of the queue, k equal to 0, k is less than size, the queue size. And then we take the element of the front, whatever element is in the front, we pop that out from the queue. And then we move it across all the four directions. And if we see that we have a fresh orange setting on that particular coordinate, we rot that orange. And by rotting, I mean that I'm changing the value present in the coordinate to 2. Okay, if it is 1, I will change to 2. Okay, and once I'm changing to 2, now that particular rotten orange can basically rot another orange after that iteration. So I will insert it back into my queue. Okay, so this is the idea about how you can solve this. Okay, so we since already have declared a direction vector, so with the help of that particular vector, we are traversing across all the four directions. And after that, if it is a valid direction and the grid is not equal to 1, it means that it is. Hmm. So not equal to 1 means it is a rotten orange or it is an empty cell. But if not, we will just make the value equal to 2 and push back. And at the end, we have to check that whether count is equal to 0. In that case, we will return maximum of 0 or rest. Okay, rest will basically contain the answer, the total amount of time you are taking. If it is, so if count is equal to 0, basically means that the total number of orange was CT initially, and once we were running the BFS, we were decreasing the amount of oranges. So if, let's say, if count is equal to 0 at the end, it means that we have processed all the oranges, and none of the oranges are yet fresh, are remaining to be fresh. So that is the reason we are checking this, and if not, we are just returning -1. Okay. So this is how this particular code works. So can I please have a +1 in the chat box if you have understood it, or if you have any doubts, you can just write in the chat box. Okay. Rishit, is the code clear to you? Can I please have a +1 in the chat if it is clear to you? Yeah, thank you, Rishit. Let us move to the next part of our discussion. So that would be yeah. So that would be basically discussing about pre-computation using DFS. Okay, I won't take much long time, and I will just discuss it very quickly. So I will just show it to you the code that will help you understand this concept. Okay, so let me share my Sublime text, and then yeah. So the people who are joining after yeah. So this is pre-computation using DFS. So why exactly do we need this pre-computation using DFS? Is that, let's say you are given a tree and you are asked to find the subtree sum. Okay. So how will you do that? For example, you are given a tree and you are asked that you will be given q queries, and for every query you will be given a vertex number, and you have to find the total number of vertices that are present in that particular subtree, or the subtree sum. If every vertices has been given a particular value, you have to return that subtree sum. So if you are running DFS or BFS every time for every query, the time complexity will increase. Okay, because Q will be around 10 to the power 5, and the number of nodes are around 10 to the power 5. In that case, what will happen? The complexity will become 10 to the power 10. So what you have to do is that you have to do a O of 1 operation inside the query. So before that, what you can do, you can just pre-compute using DFS all the subtree sums. So this is the word. So this is basically the code that will help you do that, right? So you write a DFS code, you take the vertex, you take the parent. Now, once you're entering into the vertex, you just add the value of the vertex, because if you are entering into the root, so root will be, let's say, the vertex number 1. So you add 1 to the root. After that, what will happen? You go to the usual DFS code. Now, once you are coming out of that code, you just add the particular subtree sum of the child. So the subtree sum of vertex is equal to the subtree sum of the child. Okay. The same logic can also be applied to make sure the number of even count or not. Okay. So subtree sum of child is equal to the subtree sum of the vertex is equal to the child. So after you run this DFS algorithm, so in this vector of subtree sum, you will have all these subtree sum pre-computed. So you can definitely just write subtree sum of b, and this will give you the answer. So this becomes O of 1 inside the Q. Okay. So this is how it is proceeding. So hello Pradeep, welcome. So this is a very simple explanation on finding pre-computation using DFS, and it occurs. And this particular concept usually occurs in a lot of problems and interviews, so I thought of discussing it. Okay, so did you properly understood it? If you've understood this concept, can I please have a +1 in the chat box? all the leaf nodes. So the idea is that the value of the subtree sum for all the leaf nodes will be 1, and once you are progressing to the upside of the okay, yeah, I think now I am audible. So once you're progressing to the upper side of the tree, basically what happens, you just keep on adding 1 to every node as you are progressing upside. Okay, so when you are returning back from the DFS calls, so that will basically keep on accumulating the sum, and the root node will basically contain the value, which is basically the total number of vertices in the tree. So every time you get a vertex v, you can just write the subtree sum v, that will give you the answer in constant time. So this is the optimization that we can basically do, that will help us solve this question. Okay, so I think I am audible. Can you please confirm? Can you please do a +1 in the chat if you understood my explanation? Okay, yeah. So let's wrap up our session for today. So this is what it is for today. Okay. So I would request all of you all to kindly check out the complete interview preparation course that you have. You will find the link in the description. And if you are preparing, yeah, so that even count is basically a similar question that you can do using the same concept. That is basically counting the total number of even nodes in a subtree. Okay, so you can just have a different array. Same, you can just have another array called even count, and you will only increase the value if the value of the vertex is even. Okay, so same question, but this time a slight modification. So the idea remains exactly the same. Okay. So this subtree sum is basically finding the total number of nodes, and even count is basically finding the count of nodes in that subtree which has an even number. So root node is an odd number, so we will not count that particular node. But the node number 2 will be an even node, so we will count for that. Okay. So that is the subtree sum and even count. So I hope this part is clear. So yeah. And I, okay, Rishit, thank you very much. So, Rishit and everyone out here, so if you're preparing for your interviews, I would definitely recommend you all to check out the course called Complete Interview Preparation on the GFG platform. And it is an extremely well structured course that will most certainly help you in your interviews. Okay, so this was, let's wrap up this session for today. And we'll be again meeting next month with another series. So this is the last session of last day of the series, and I hope that I have been able to deliver good quality content to all of you, which has proved useful. So yeah, I could see Rishit and attending more majority of the sessions on a regular basis. So Rishit, I would like to thank you very much for that. Okay. I have already given my introduction in the beginning. You can find me on LinkedIn. My name is Gaurav Kumar Shah, and if you are, you can just ping me up on LinkedIn if you would like to get connected with me. Okay. So yeah,